Hello, Algebra Scholars. This part of section 5.4 is called perfect square trinomials, and you can actually use what we learned in section 5.3 to factor all of these problems. So if you like, you can completely ignore me on this section. However, there are some cases of trinomials from section 5.3 that come in the form ax squared plus bx plus c, where you can definitely factor them using a factor sum chart, but if you know the technique of perfect square trinomials, you might make your life a good deal easier. So if you're still listening at this point, I think you might learn a thing or two, and it might be worth your time. So perfect square trinomials, we call them PSTs, first of all have to be trinomials, and then they either come in the form of a squared plus 2 times a times b plus b squared, or they come in the form of a squared minus 2 times a times b plus b squared. If you can show that they come in the first form, you don't need to do a factor sum chart. You can just then say that the problem factors into a plus b times a plus b, or a plus b quantity squared. And if it comes in the second form, then the trinomial is guaranteed to factor into a minus b quantity squared. Let me give you an example. So here's an example where if we tried to do a factor sum chart, well, first we check to make sure the problem is in the right order, and it is, and we could check for a GCF, and there isn't one. And so if we went to a factor sum chart, we would need to find two numbers that multiply to 3,136 and add up to negative 112. So as you can see, the numbers are massive here. So knowing the rules for a perfect square trinomial might save you some time, and here's a case where they would. So just as a review, perfect square trinomials need to come in this form, which factors into a plus b squared, or they need to come in this form, which factors into a minus b squared. So notice in these two forms, and grab my highlighter, the first term and the last term are both positive and both perfect squares. So let's check to see if we have that. Is the first term a perfect square? Is there something we can square to get 49x squared? And the answer is yes, we can square 7x. That's what we call A. We then see, okay, is there something that we can square to get the last term, to square 64? And the answer is yes, 8, and that we call B. That's the first criteria. So we have a squared, we have b squared. We now need to see if we either have plus 2 times ab or minus 2 times ab. Well, we can pick which sign we want by using the sign of the middle term here. So if it's plus, it's plus. If it's minus, it's minus. And all we need to do is fill in a and b right here and here, and see if what we get when we multiply these three things out matches what's right here. If it does, we have a PST, so let's check. 8 times 7x is 56x, times negative 2 is negative 112x. So this means we have a PST, yay. So we don't have to do a factor sum chart. We see, okay, we have this form, a squared minus 2ab plus b squared, so the problem just factors into a minus b squared. And that's a lot easier than finding two numbers that multiply to 3,136 and add up to negative 112. Let's do another one. In this example, the problem is in the right order. There is no greatest common factor. Let's skip the factor sum chart and let's check to see if we have a PST. The first term we see is a perfect square. We're squaring 3x, so that's A. The last term is a perfect square. We're squaring 7, so that's b. We just now need to see if the middle term is negative 2 times a times b. So let me fill in b here and a here and see if it matches negative 42x. So 2 times 7 is 14, negative 14, and negative 14 times 3x is, yes, negative 42x. So this is a PST, therefore it factors into a minus b squared. We know it's minus because the middle term is minus. So this factors into 3x, 3x minus 7 quantity squared. Now, if it turns out that the middle term doesn't match, then you have to go back and do a factor sum chart and try it the way we learned in section 5.3. You don't say it's prime. All that you could say at this point is, well, it wouldn't be a PST.